Yowzers. We've got some spectacular imagery for you today, let me tell you. What you're seeing there is an X-class solar flare. And thanks for tuning into the Smash News Network, least busted name in news. We're bringing you some fresh imagery today. That happened just earlier this morning. And we actually slowed that down. That's only a few hours. That's just 1 through 6 o'clock Universal Time this morning. There was a coronal mass ejection associated with this, and there's plenty more to talk about besides just the X-class solar flare. So thanks for stargazing with us. And let's get some more images here onto your screen. Here's a slight zoom out. That's 131 plus 94 angstrom from the GOES-R. And here's a full disk view. That's only 1 o'clock through 6 o'clock Universal Time today on March 29th. As far as sunspots, there are lots. And I think we said yesterday the likelihood of an X-class flare was 60%. The likelihood of an M-class flare was what? I said 80% or something like that yesterday. I can't remember exactly. But yeah. It's called understanding the physics and the data and then coming through. Now, we've got some new sunspots that don't have names yet. At least 2 likely new names sunspot groups. This one up here is already quite significant. That's already what I would call a major sunspot in the Northeast. We'll get to some more in-depth analysis of that toward the end of the video, just before our meteorology segment. So today's featured product, by the way, is Shartlight. Yeah, the Shart lighting. And of course, there's a lot of Shart lighting that goes on the internet. And what it boils down to, folks, is that gaslighting is a psychological abuse where people attempt to get you to believe the past differently than it actually occurred to do things like advance their ridiculous narratives. So you might find this happening all over the internet. I'm sure you probably do find it happening on the internet. Remember, folks, consumer tip, never try to gaslight somebody who has a better memory than you, as that is just a recipe for disaster. And a failed attempt at gaslighting does nothing but undermine your own credibility. So don't Shartlight. And don't forget to demand accountability from those who do Shartlight. So if somebody attempts to gaslight you and fails at it because your memory is better, or you just don't believe their nonsense, let them know that they've Shartlighted. It's like trying to light a fart with a lighter and then just pooping on your own hand. It's a perfect metaphor for destroying your credibility with failed attempts at gaslighting. That's our featured product, and our featured website is smashomash.com/smash team. If you want to support the channel, thanks to everybody who has considered joining at the gold or silver Smash Team level. There's also a bronze level there. We send out email alerts to everybody who's registered for email alerts on the website. We launched it back in October of 2021 to replace Patreon with a site that's more feature-rich. We are still on Patreon as well, so visit the other links on the homepage at smashomash.com and welcome to the Neo Renaissance. One of the links you'll find there is the link to the Hemp Lucid shop. So this video does include a paid promotion. So if you are shopping for Hemp Lucid products, why not enter the promo code SMASHOMASH to save some dough or save some cash on your checkout? Or you can just visit the link below the video to shop that way for your CBD, mushroom gummy, and many other solutions. Smashomash.com is the homepage, so visit us there. If you're unwilling to open your cobweb-encrusted wallet and send us a few bucks per month to continue producing this content, help us out with clicks. Visit us on social media. Press the share button. Leave a nice or even a mean comment. Press the thumbs down button, or perhaps even the thumbs up button, especially if you'd like to see us do a live stream today. And let's see what's going on as far as volcanic eruptions. Shivaluch, featured in this image, is indeed erupting on the Kamchatka Peninsula. And also Krakatoa. There's a great image of Krakatoa. the tiny volcanic archipelago, the tiny volcanic island there, producing a bit of an ash plume indeed. So let's see what else is going off here. Again, Shivaluch, it's exploding. It's producing a 15,000-foot ash plume at the moment. Also, extrusive activity is creating some new real estate on the Kamchatka Peninsula. Bezimiani now back on the list, now exploding and producing a 13,000-foot plume of volcanic ash. That's a flight level 130 over the central Kamchatka Depression. Abiko also exploding, flight level 080. It's an 8,000-foot ash plume. Sakurajima exploding, 8,000-foot ash plume. Subanose Jima, 6,000-foot ash plume. Krakatau, no indication on the size of the ash plume there, but strong Vulcanian-type explosions over the past 2 days showing up there. Also seismic signals. Popocatépetl exploding, flight level 200 over central Mexico. Fuego exploding, flight level 150 over Guatemala, and not sure if Sabancaya is erupting. It's unable to be detected. Please do not pole vault the caldera. Next global seismicity, no major quakes over the past 24 hours. There's a 90-day graph to put things in context for you. A bit of a 7-magnitude earthquake drought here. And here is the list of 5+ magnitude quakes in the past 24 hours. There was a 5.0 at the Santa Cruz Islands there, north of New Zealand and east of Australia. The Solomon Islands had a 5.2, pretty close to the Santa Cruz Islands there. We have issued an earthquake watch for western Mexico. That should expire in about 2 days. It all has to do with viewing the ionosphere and the total electron contents. There was also a 5.0 at the Fiji Islands. That one over 600 kilometers estimated depth. If that occurred at the surface, that would be like a high magnitude 6 earthquake. Japan had a 5.1 just a few hours ago at 8:53 Universal Time this morning. And let's get back to space. Here's the past 24 hours. And that's a great composite that we like to use. That's 195 plus 304 angstroms. Great at showing filaments, ionized helium, and some extended coronal features. And again, we've got a ton of imagery today. Let's briefly go around the horn. Likelihood of large solar flares remains in effect for the western portion of the sun. Some large filaments hanging out up there in the northwest. Also down in the southwest, a bunch of filaments down there. The biggest filament on the Earth-facing portion of the solar disk is the Shaquille O'Neal filament, which we named yesterday on yesterday's video. Right there it is. And it is quite beefy, like the retired NBA player. What's that? You'd like a closer image of that? Okay, we've got that for you. There's an even closer image of the Shaq filament, the Shaq solar filament, folks. If you'd like to name filaments after living people, hit us up over on Twitter. Follow the hashtag SpaceWeather, SpaceWX, and hashtag NameThatFilament. And there is the northeastern limb. This new sunspot up here is what I would call a major sunspot group. It's already got 3 large umbrae, and it is magnetically complex. We'll show you high-res imagery of that between our bonus features segment and our meteorology video. We're putting them all together, folks. Putting them all together into one convenient rundown of the weather, all the way from the sun to the U.S. 24 hours of GOES R 171 angstroms shown here. And here's 24 hours of GOES R 304 angstroms. All right, let's talk about some other space weather stats like the 10.7 centimeter radio flux, which is currently at 159 solar flux units. If you're not familiar with the radio flux, it's the proportional data set to sunspot number discovered back in 1947 by some Canadian radio users. You can see how proportional that black line is to that red line. The black line is the radio flux, and the red line is the sunspot number. We made it back over 140 there for the sunspot number, which is now dipping once again. We are seeing this support level continue around 155 solar flux units for the 10.7 centimeter radio flux. Space Weather Enthusiast dashboard suggests that NOAA might be watching our channel. As we said, we're expecting the coronal hole high-speed stream to arrive a little bit earlier, like by midday tomorrow. And indeed, NOAA has now changed their forecast to showing some geomagnetic unrest there. So I'm not sure why they're expecting it to end so early. It all does have to do with the magnetic field orientation of the incoming solar plasma, but we'll just have to wait to see what happens there. Don't be surprised to see a KP6 March 30th to March 31st, possibly even into April Fool's Day. We are expecting a bit of an extended coronal hole high-speed stream for this. You could see a KP6 into April here with the current coronal hole situation that we have. So let's look at Earth's magnetic moment from space, which is showing a very low magnetohydrodynamic pressure environment, which is what's depicted on this imagery. That's the past 4 hours. And nanopascals are magnetohydrodynamic pressure. And it looks like a very low pressure environment, which means we should see a very significant signal, assuming nothing changes between now and tomorrow when the coronal hole high-speed stream shows up. Here's Earth's magnetic moment from the ground, also pretty calm here over the past 4 hours. It's geospace delta B there changes to Earth's B field, the B field being the field that goes through the magnet. Don't worry, we'll show you the sun's B field momentarily. Planetary K-index is a measurement of global geomagnetism. It's an average of Earth's overall geomagnetic environment. Currently quite low. KP is 0.67. Very geomagnetically calm conditions. And let's go to Lagrange 1. And by the way, the reason that we show this diagram of Lagrangian points is just to remind our viewers that the solar wind is measured at Lagrangian point 1 outside of Earth's magnetosphere. So you've got these different Lagrange points here. These are the gravitational equilibrium points between the Earth and the sun's gravity, which means you could put a spacecraft out here at Lagrange 4 and it would orbit this location with very little use of fuel, meaning you could put one out there for an extended period of time. And we're really dying to see an X-ray detector. We need an X-ray detector here at Lagrange 5. Preferably, I mean, that's the most important spot. We need like a stereo AX so that we can have an X-ray detector out there. We're interested in the possible anisotropy of solar flares. We'll have to save the explanation for that for later videos. In summary, basically what we mean is that there is a possibility that a solar flare may show a different intensity at a different viewing angle. So if you're viewing it from here, the solar flare might be a C-class flare, but if you're viewing it from over here, the solar flare might be an M-class flare, for example. Anyway, here's the real-time solar wind info. We are seeing an increasing field here, so we're seeing the field get stronger and dip into the negative territory. So that red line up there, that's the vertical component of the magnetic field, otherwise known as the BZ. The BT is the total field. Current conditions are for that. BT of 9 nanotesla, BZ of -3. Now, if we see that get significant, if we see that stay in the negative territory, we'll see the KP come up a little bit. But we're expecting a big density increase sometime around midday tomorrow. So it could come a little earlier, but midday tomorrow is already an adjustment of the initial forecast for the coronal hole high-speed stream. Current conditions are about 1.5 protons per cubic centimeter. That's the solar wind density. Solar wind velocity, about 400 kilometers per second. We can expect to see a major signal from that coronal hole high-speed stream. Next, the GOES magnetometers here showing some big divergences in the past 24 hours. You can see this divergence around noontime local time for the GOES 16. That's what that red N means. And then another divergence just before midnight local time for the GOES 18. So a little bit of magnetic turbulence happening there in Earth's magnetic fields. The GOES magnetometers on the GOES 16 and GOES 18, those are located in geosynchronous near equatorial orbits. Their altitude is like 23,500 miles of altitude. And next we'll look at the heliospheric current sheet. And thanks for leaving comments, Mike Bordages and ePector 58. So when we refer to midday, we generally keep the videos in universal time, which does coincide with Greenwich Mean Time, except for around daylight savings, as they have a different schedule for that. So we just stick with universal time because we have viewers from all around the world. So here's the heliospheric current sheet, and Earth is right in the middle of a South Pole-oriented current sheet. Fun fact, there is a growing sunspot just about to be facing stereo A. So if you see right here, you see that sudden growth right there? That is the growth of a sunspot. So that is an unmistakable thing that we see there with the potential field surface source lines. Looks like a big spot, and it'll be in the view of stereo A here in about a day. So that'll be something to keep an eye on here. And this data right here, this top view ecliptic plane field plot, which is, by the way, part of the National Solar Observatory, this is one of the most important data sets we have to solar forecasting if you understand how to interpret this data. So, yeah, growing sunspot over there in the east. I suspect that is probably in the northern hemisphere, but without further data there's no reason to conjecture. So we talked about the sun's B field. Here it is depicted in these blue potential field surface source lines. That is the sun's B field, the B field being the field that goes through the magnet. Here the solar polar fields are depicted in green for north on the opposite side of the sun, and red on the Earth-facing portion of the sun. Welcome to the South Magnetic Pole. Yeah, the South Magnetic Pole. Next, our coronal hole line of sight plot, and lots of South Pole-oriented coronal holes here. In fact, all of the coronal holes that are visible at the moment, besides the one up here at the north heliographic pole, are South Pole-oriented. So here's the data from yesterday plus today from the SDO. We'll zoom in a little bit there just to give you some more depth of field. A little bit more detail for you there on those coronal holes. We'll zoom back out. So these are all of South Pole orientation here. South, 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 that's south. And there is a North Pole one up here, but that's the only, that is the only North Pole coronal hole visible from Earth at the moment. So that brings us to sunspots. And there are still lots of sunspots here, and the likelihood of large solar flares remains at nearly 100%. So we already saw one X-class flare happen. Don't be surprised to see more. They could come out of the northern or southern groups. And also don't be surprised to see a large flare from this group here, as that group has recently become very magnetically complex. And let's show the intensitygram here once again. There's the SDO intensitygram. And that is yesterday plus today. So looking at the latest image there, this sunspot group is important. It is quite magnetically complex. It's even grown since we did show prep. Likelihood of major solar flares, especially in that area, the western limb. Next, looking at energetic particles, that X-class flare did not produce any relativistic particles there to be measured by the GOES 16 proton flux. No relativistic particles there. And there's the X-class flare. We brought up the one-day graph. We usually show a 3-day. Peak flux was right around 2:36 universal time. And that was an X. What was it? An X. 1.27? It was an X 1.27, I think. Somewhere around there. And let's take some more looks. We paused this one here in 94 angstroms, right around that time. We're going to play this here. We're going to actually reload that because that's going to contain some garbage. And let's just bring that back and show some great slow-mo imagery. And thanks for your comment, ePector58. We are writing a paper to explain the solar sunspot cycle, so thanks for that info, but that's a little bit basic for the channel. We believe we've uncovered the mechanism that underlies the solar sunspot cycle, so we figured it's kind of important. Anyway, there are some slow-mos of that X-class flare. SDO 94 angstroms. Here's the past 24 hours in 131 from the GOES-R. And you haven't seen enough of that X flare yet? Okay. Here we've added 94 angstroms to the GOES-R. That's just the flare moments. And there is one more set of close-ups for you. That is 131 plus 94 angstroms from the GOES-R. That is 5 hours of data there. 1 o'clock to 6 o'clock Universal Time this morning. How about some flare forecasting? Our channel does it, as we appreciate things that have predictive value. All right, so before we look at things like coronal mass ejections, let's take a look at what's going on overhead, just to give you a moment to orient yourselves before we move into the coronal mass ejection portion of the video. So the sun just rose here. We'll be talking about a planetary alignment later this month. And, of course, if you're viewing the evening sky, you may see Jupiter and Mercury there. If you're viewing the morning sky before sunrise, you may see Saturn rising ahead of the sun. And let's take a look at coronal mass ejections. But first, a solar system forecast. So here is the 1 week forecast for heavenly bodies, as Earth is in a very lonely portion here, although Venus and Mercury are speeding around to catch up. Here's where things will be in 1 week. We'll be about a day from a full moon there by April 5th. And let's move to coronal mass ejections. So here are yesterday's images. And of course, yesterday's thumbnail featured a spectacular CME. See our videos on YouTube, youtube.com/smashomash for yesterday's daily space weather video. That is not an Earth-directed coronal mass ejection. Here are today's images. We've got 35 more frames for you there. And that X-class flare was associated with a coronal mass ejection. It was off to the west. Does not appear to be Earth-directed. Here's some more information from Stereo A. We'll let those play through here for a quick moment. So just a little bit more background, ePector58. I realized back in 1994, when I was in college astronomy, it might have been 95, but in the mid-90s I realized that there's a hole in cosmology, and the hole is understanding heliophysics. So I've recently come back, as about 15 years ago I realized it's way too easy to forecast the weather. I needed greater challenges. And so here we are, writing a paper explaining these solar sunspot cycles and solar polar field reversal cycles. These are 24-hour videos from that's the GOES-R 195 angstroms wavelength and the Soho-Lasco C2 and C3. Let's get in one step closer there. So that coronal mass ejection associated with that X-class flare does not appear to have any Earth-directed components. It is well off to the west. That brings us to solar filaments. So here's the ground-based Cerro Tololo, Spain. No, El Teide, Spain, rather. Cerro Tololo is Chile. Anyway, bunch of filaments here. We could name some of these up here. Also, this one up here could use a name. Again, if you want to name filaments, make sure you join us over on Twitter. We're all over the internet at Smashomash. Again, links on the homepage at smashomash.com. Lots of filaments. Likelihood of additional coronal mass ejections remains nearly 100%. Here's the past 24 hours in this spectacular GOES R 195 angstroms wavelength. That's a 24-hour video, and here is the past about 2.5 hours from the GOES 16 SUVI. So that's typically what we stream on the Twitch channel throughout the day, as we don't want to miss any spectacular phenomena. And we did capture that X-Class flare. You can see our videos. We leave those videos public. So those are on the Twitch channel if you want to view the X-Class flare there in the GOES 16 SUVI. Feel free. I think that stream was like 16 hours in length. Next, our bonus features segment, starting out with charging hazards. And we've got some internal charging here by high-energy electrons getting inside of satellites. The internal circuitry can be disrupted by those internal charging hazards. And there you go, all the way from the central Atlantic Ocean all the way into the West Pacific. Significant surface, well, minor surface charging hazards there, but over a very large area. The GOES electron flux here, a little bit higher than I think expected here. So we can expect a major dip in this tomorrow around midday. Again, when the coronal hole high-speed stream high-density wave shows up, you can expect to see that GOES electron flux crater. That'll be one of the many signals indicating a coronal hole high-speed stream. Here's a NOAA forecast for relativistic electrons there, a little bit higher than forecast. I'm not sure if I refuted that yesterday or not. See yesterday's daily space weather video to see what my forecast was. I don't even know if there was one, but check it out anyway if you've missed it. And by the way, if you're viewing the videos on BitChute, you're missing like 90% of our content, so you should subscribe over on YouTube. There are all kinds of stuff that you're missing by only viewing on BitChute. And if you're avoiding the YouTube platform entirely, we completely understand your reasoning. Thanks to our YouTube viewers for tolerating the pathetic, putrid, and disgusting censorship on the YouTube platform. That's the one-year graph of relativistic electrons. Next, we'll show the F-flare of the ionosphere and the animation of the vibrational frequency therein. It's the bridge between Earth and space at about 300 kilometers of altitude. It's the F-flare. And here it is in its vibrational glory. So we show the previous day each day on the channel to show any significant anomalies in the ionosphere. Sometimes immersing yourself in the data causes you to end up with answers to questions not asked, which is what happened with the explanation for the sunspot cycles. We used a combination of deductive and inductive reasoning. And frankly, I don't like the explanation. I don't like my own theory. It just appears to be the truth. So the truth is out there, folks. And we're about to complete a paper explaining it. Anyway, here's your anomalygram. That's anomaly in megahertz from a 30-day median. As we're just about to exit the most geomagnetically effective month, historically speaking, the month of March. So pushing to the end of March here. We did have one X-class flare at least. I'm not exactly sure. I don't keep count of these things. But here is our latest image. That's 11:30 universal time ionogram. And there's 11:30 universal time anomalygram. We'll also show the total electron content forecast to show you the most likely places for GPS errors. Also the possibility of, dare I say, some actual earthquake forecasting. Here's your total electron content forecast. That's the free electrons to about 12,500 miles of altitude. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And those free electrons can cause signal refraction. So they're somewhat orderly here. And when we see a huge dip in the electron flux caused by the coronal hole high-speed stream, we can expect to see this become a lot more anomalous. Electrons will be out of place. We'll also show the total electron content anomaly over North America. And check it out, some large anomalies happening once again here. That's a significant departure from the 10-day average there over parts of the north-central U.S. We'll let that play through one more time. And then we'll show just the U.S. There's the anomalygram for just the U.S. total electron content. And let's take a look at the high-res imagery before we go to meteorology. So there is your intensitygram, there is your colorized magnetogram. First things first, this new sunspot group right here is quite magnetically complex. So as you can see there, it is already beta-gamma class. Maybe delta. Just barely. It's pushing the boundaries of being delta class. I'll say beta-gamma class for sure, though. We've also got a new sunspot likely to be named here. Also, probably 2 more in the southern hemisphere, so we can expect 4 new named sunspot groups at least today. Here's the full disk rock back. Looks like a new sunspot formed down here as well. Well, maybe not. Just a plage. Anyway, you can expect some new named sunspot groups today. And again, expect a large sunspot to be rising in a couple of days there. We showed you why on the colorized magnetogram. Now, thanks to our YouTube viewers once again for tolerating the disgusting, putrid platform of YouTube, which, you know, promotes nonsense, propaganda, and disinformation while suppressing facts. Anyway, the truth is out there, folks, and that's what our channel is about. Not about propaganda, grifting, or nonsense, just the facts. So press like, subscribe, share, etc. Tell your friends and foes about the channel. YouTube doesn't seem to like to recommend it, even though the channel's monetized and plays advertisements. Also, don't forget to join us on Twitter. And if you think free speech has been restored by Elon Musk, we would invite you to please snap out of your delusional nonsense. Elon Musk has not restored free speech. Shadow bans, aka deboosting, continue on the censorship-rife platform. Also Meta and Google platforms. Also Apple. Anyway, we've moved to meteorology, and what we're looking at here is the UV index and erythemal dose. So basically, that is your most likely places to get a sunburn. As the northern hemisphere has reclaimed the more direct rays of the closest star, due to the axial tilt of the planet, if you're wondering. Anyway, let's break out the surface winds and the jet streams blast through the meteorology segment. So there is the surface wind scenario of the eastern world. There is the jet stream scenario for the eastern world. Jet stream of the west depicted here. Surface winds of this side of the planet, right here. Surface winds of Europe, Africa, and the Middle East, shown here. It's windy in the eastern Mediterranean. And here are the jet streams. Next, our clouds and fog map. This is some real-time data here, more or less, from the GOES Interactive Weather Satellite Suite. That's 3.9 nanometer infrared radiation showing clouds and fog, despite most of that map being too dark to use the visible satellite. Next, your weather.gov map. If your location's lit, head to weather.gov and click your location. Looks like we've got some winter storm watches for Arkansas and Tennessee. Could that be right? I suspect those are frost advisories. Nope, pretty sure those are, yeah, those must be frost advisories. Anyway, I heard about an avalanche in Utah. Let's take a look at some forecasts here. So here is your GFS pressure and precipitation forecast for the next 72 hours. Again, there's some ice coming to, let's see, some ice coming to Minnesota, Wisconsin, and Michigan, it looks like. Also some parts of the Northeast. Forecasting some ice there. Northern New York and parts of New England. Here's your total accumulated precipitation forecast based on the same model, the GFS 72-hour. And since some of that precipitation will be in the form of snow, California, here is the 72-hour GFS accumulated positive snow depth change forecast. It is in inches, and quite a bit of snow continuing here. Significant snow coming to Pennsylvania, most of New York, and feet of snow continue to fall in California. Also South Dakota expecting a significant coating of the entire state. Let's continue on. We don't want the video to be too lengthy. Here's our windy.com imagery. Give that a minute to initialize. It's well worth it. That is the visible satellite for windy.com. And here's our lightning mapper. Texas had some significant lightning. Brownsville, for example. Come on, come back. You can do it. You can animate. I have faith in you. That looks like crap. Let's move on to a real-time lightning map. So here's our real-time lightning map from lightningmaps.org. Next time you hear thunder, check it out. It could save your tuchus. That's a term I wish to never use again. All right, so there's the current lightning situation. Looks like we've got bandwidth issues. Let me pause for station identification. This is the Smash News Network, least busted name in news. I'm going to press refresh just to see what happens. There we go. All right, it looks legit. Some sparse lightning happening here. No concentrated cells occurring at all. Here's your U.S. Doppler radar map. It shows vertical motion in the air column. There is the lower 48 view. Here is clouds and fog. Part of the NASA GOES Interactive Weather Satellite Suite. It's the 3.9 nanometer shortwave radiation map. And there is the 6.19 nanometer radiation infrared. That's water vapor. It shows things like upper level winds, dry air as well as moist air. We've got high pressure moving into Texas. And we've got high pressure here moving off of the North Carolina coast. How do I know it's high pressure? Because dry air is more massive than moist air due to the molecular mass of nitrogen versus water. Hopefully that helps. Hopefully you understand atmospheric physics. Hopefully you enjoy the spectacular imagery that we showed you today and the chock full of facts. You're condensed matter, and we want your videos to be condensed as well with a ton of information. So here's your recap. We're closing things out with the water vapor map. So thanks again for tuning into the Smash News Network, least busted name in news. Congratulations, I realize the channel exists, and don't forget to visit our links. Support the channel. If you prefer to see these videos continue to exist, remain publicly visible and free for all to view. And also don't forget to visit the links over here and here and here.